Welcome to clickmyproject.com. Let us discuss about the dynamic spectrum allocation for the downlink of OFDMA-based hybrid access cognitive femtocell networks. Let us discuss about the abstract of the product. The cognitive femtocell has emerged as an exciting technology to solve the indoor coverage problem in future cellular networks. Recently, several technical issues for the cognitive femtocell have been studied. For example, spectrum sharing and interference mitigation. However, the incentive method that is very important for practical hybrid access, cognitive femtocell deployment has not been well investigated. In this paper, propose a new dynamic spectrum allocation method for the hybrid access cognitive femtocell. In the proposed method, the macro-based station allocates a portion of subchannels to the femto access point to support the FAP to serve the macro users. Then the FAP allocates the subchannels and power to maximize the femtocell network utility, whereas the throughput of the served macro users is guaranteed. Moreover, we formulate the corresponding resource allocation problem as a sum of utilization maximization problem and propose an optimization method to solve it via dual decomposition method. Simulation results shows that both the wireless service provider and the femtocell would benefit from the proposed method. Femtocells are smaller telecommunication base stations that can be installed in residential or business environments, either as single standalone items or in cluster to provide improved cellular coverage within a building. It is widely known that cellular coverage, especially for data transmission where good signal strengths are needed, is not as good within a buildings. By using a small internal base station, femtocell, the cellular performance can be improved along with the possible provision of the additional services. Let us discuss about the flow diagram of the product. Initially, in the system model, OFDMA-based architecture, two-tier network architecture is considered, also deployed with base station, femto access point, and macro user deployment. The wireless operators allocate the part of spectrum resources to FAP by using these three deployments to achieve the maximum network utility and the throughput. And then the next is a dual decomposition method. The dual decomposition method is split up into two subproblems. One is application layer and another one is a physical layer. The optimization of problem is mixed binary integer programming problem and is non-convex. However, since a time sharing condition is satisfied in the OFDMA systems with a large number of subcarriers, the duality gap is proved to 0. Therefore, in this paper, the Lagrangian dual method is employed to derive the optimal solution. The dual function consists of two sets of variables, the variable dn for the application layer and the variables lambda m and lambda n for the physical layer. The overall sum of utilization maximization problem can be solved by using the dual decomposition method. Next, update the theta use the subgradient method. When update the value of theta in the subgradient model, we need to obtain the solution of both application layer subproblem and the physical subproblem. The network utility of the femtocell network is reached when the values of theta are convergent. And then the dynamic spectrum allocation method. The dynamic spectrum allocation method is proposed to support both wireless operator and the FAP to adapt a hybrid access in the cognitive femtocell network. To achieve the same QoS of the immune in the indoor communication consumes less subchannels compared with the outdoor communication. On the other hand, the macro BS would improve in spectrum efficiency by saving a part of the spectrum. To implement the dynamic spectrum allocation method, corresponding protocol is designed and finally estimate the network utility. And then the final performance analysis. The final performance analysis in the network utility converge, the performance analysis is completed. Otherwise, is repeated the dual decomposition method to solve the subproblems. Yeah, here we discuss about the running procedure for the product. Select the main file for executing the product. Now, by executing the file, many outputs are displayed. So these all outputs are related to our flow diagram. First of all, this is our system model. This is a macro base station. The macro base station that is directly transfer the data to the macro users. So is a weak, so the SNR is reduced if the femto access point, strong access point, that is indicated in the green color. So the next graph is the utility function. So this is a utility function graph. In the utility function graph, the utility is a target rate and this is utility. The target rate is megabits per second. So the next figure is shown in the So this is the next figure. In this next figure, there are different performance with the different schemes. That is OPTHA and EACA and OPCA and DSAHA. So the OPTHA means the optimal allocation for traditional hybrid access and the equal allocation for closed access, optimal allocation for closed access, and dynamic spectrum allocation for the hybrid access. So this one is our proposed method. The red is the high for all the comparison graphs. So this is the next graph, the actual rates for each end user with proposed dynamic spectrum allocation hybrid access method. The blue indicates the femto user 1, femto user 2 and femto user 3. This is the macro user. So these are the achievable rates, megabytes per second. So this graph explains the actual rates of the each. Then this is the next graph, number of subchannel used by the macro users with different schemes. So these are the different two schemes. OPCA is a optimal signal method and DSA is a dynamic spectrum allocation hybrid access method. So these are the number of channels. So this graph indicates the number of channels used by the macro users with the different schemes. So this is the next graph, network throughput with different number of send channels. So number of send channels is 1 to up to 9. This is the next network throughput, that is megabytes per second. So this is our proposed method. Proposed method is a dynamic spectrum allocation hybrid access. This is our existing method. So the next graph shows the number of send channels through the network utility. So this one is our proposed method, dynamic spectrum allocation. This is our existing method. So that is very reduced compared to the our proposed. So in this graph, network throughput with different number of negotiation channels. So the negotiation channels is the blue is our proposed method and there is a black is our proposed method. So the black is k is equal to 3 and blue is k is equal to 5. These are our existing method. This is the number of negotiation channel versus the network throughput. So this is the final graph, network utility with different number of negotiation channels. This is our proposed method and the black is denoted also our proposed method. So that is the same procedure for the network utility. K is equal to 3 and K is equal to 5. So that's all about the running procedure for the product. Thank you for listening the video.